Hey, welcome back. Today we're going to be talking through the basic structure of an atom, so basic atomic structure, and how to read the periodic table. So maybe you're a high school or even a middle school science student and you need to learn more about this, or maybe you're just interested in science-related content. We're going to talk through it, but first I do want to point out something that you probably have seen before. Maybe you've done this as well, played with a balloon and rubbed it against your hair, and after a while the balloon and the hair will start to attract each other. So it's an interesting phenomenon, and it does get at some of the ideas that we're going to be talking about today. Now, I'll need 2 or 3 lessons to get through the material so that you can completely understand what's happening here. But our lesson for today will get us on the road to understanding how that can happen, how you can get a balloon that seems to attract hair and vice versa just by rubbing the balloon against the hair. Alright, so let's go ahead and get to it and talk about the parts of an atom. We can say that there are 3 subatomic particles that we're going to be talking about today. So the first one is a proton. Proton has a positive charge. Charge is a fundamental property of matter. There are 2 different types of charges in our universe. So there's a positive charge, what we call positive charge, and what we call negative charge. We could have called it anything, but because we called it positive and negative, that actually has mathematical implications later that we'll get into. And charge is actually hard to define other than to say it's a fundamental property of matter. So protons have positive charges. They're found in the center area of the atom. This is called the nucleus, the middle area right here, and they have a certain amount of mass. Now, we call that mass an atomic mass unit. We basically created a new unit of mass that is very similar to what a proton is. And a neutron, another subatomic particle that we're going to talk about in a moment, it has basically the same mass. It turns out that we used to think that protons were fundamental particles, but they are not. What does that mean? That means they actually can be broken down into even smaller pieces, but we're not going to be talking about quarks in today's lesson. We're just talking about the basics here. So next up we have electrons. Electrons go around the outside of the atom very fast, very quickly, and they have a negative charge, and so it's fundamentally a different type of charge than positive charges. Those opposite charges will attract each other, by the way, and if they're 2 the same charges, they will repel each other. We'll talk more about that later. And an electron has mass, but its mass is so small. It's about 1/10,000th the mass of a proton that we basically ignore it when we're doing mass calculations for the structure of an atom. We can kind of ignore the mass of an electron. And as far as we know, it's a fundamental particle at the time of this video being created. That means we think you cannot subdivide an electron into even smaller pieces. And the third type we need to talk about today are neutrons. Neutrons have no charge. The way you can remember this is neutral is similar to neutron in terms of the names. They are found in the center, or the nucleus, of an atom, and their mass is considered to be 1 AMU as well. Even though technically there's a slight difference between the mass of a proton and a neutron, they're pretty much very similar. Similar enough that we just call them 1, basically. These neutrons also turn out to not be fundamental particles. We used to think that they were fundamental, meaning we used to think that you couldn't break them down into smaller pieces. Turns out that there are smaller pieces that go into neutrons as well. Alright, so that's a little bit of background about the pieces or the subatomic particles of an atom. Let's talk about the periodic table and what you might see on the periodic table. So a very small section of a periodic table, you might see a box. And inside that box you're going to see more or less 3 things. There could be more information depending on how fancy the periodic table is. But at the very top, usually, is where you're going to see a big number. This number is the atomic number. That represents the number of protons found in the atom, and it's the most important number associated with an atom in the sense that if you're dealing with an atomic number of 2, you're talking about helium. If you're talking about an atomic number of, say, 3, then you're talking about a different atom altogether. So everything about the atom depends on this atomic number. You could say how many protons are found in the nucleus of the atom. And so next up we have the chemical symbol. So you're going to have 2 letters here, or 1. You could have 1 letter as well. The first letter is always going to be capitalized. The second letter, if there is one, is always going to be lowercase. And lastly, we have the mass number. Usually it's called the mass number. Occasionally you'll see atomic mass number, but to not confuse that with the atomic number, usually people just say mass number. And that's going to be the average number of protons plus neutrons. Because it's an average number, this is not a whole number or an integer. It's usually got a remainder over here. And let's talk about what that means in just a moment. So for instance, if you're talking about helium here, you can actually have two different versions of helium found in nature. Those two different versions of helium are called isotopes of each other. Now notice this is still helium because it has two protons. This atom over here has two protons. What do you notice is the difference between the two? Alright, well the difference is over here on the right you've got an extra neutron. For a lot of atoms that doesn't do a whole lot because remember neutrons are neutral, they don't have an overall charge. But sometimes with heavier elements, having an extra neutron makes the atom more unstable. So we're going to give our definition here of an isotope. So these are different versions of the same atom with different numbers of neutrons. There are different ways of representing this as well. You can write it kind of like this, where these numbers at the end are going to represent the mass number for those atoms. Alright, let's take this information and see if we can apply it to a new element or a new atom that I haven't given to you yet. And so if we're talking about this atom right here, it's lithium. If you want to pause right now, I will wait about 3 seconds. Now is a good time to pause and anticipate what that little diagram would look like for lithium. What do you think the structure of lithium would look like? Alright, here we go. This is going to be the structure of the most common form of lithium. Notice that we've got 2 electrons, and then now we have a third electron out in this next shell, this next energy level on the outside. We'll be talking a lot more about that as time goes on, but just know for now that electrons go around the outside of the atom, and they go around in such a way that they go around in specific patterns or almost like shells. You can think of these as whizzing so fast that it almost forms a shell, like you can't even see exactly where the electron is at any given time. In any case, this is one version of lithium. I want you to think about what the other version of lithium, what would an isotope of lithium look like? Alright, another version of lithium would look like this, where you would still have the same number of protons as before because that determines what we're talking about in terms of it being lithium. And if you had an isotope of lithium, then you might have, say, 3 neutrons in the center of the atom called the nucleus, and that doesn't change the atom. In other words, these two atoms are not all that different from each other. And again, when you get to bigger atoms, sometimes it does change things because it makes the atom more unstable if it has extra neutrons. In any case, hopefully this has been helpful. If you have any questions or comments down below, please let me know. And I hope you all have a great day. Take care.